There are so many genius card and board games out there. Yet, you find yourself sitting in front of your computer again. Gaming online is just much more convenient than having to agree on a day and time, let alone travel. But does it really have to be this way? To allow my family to play together more easily, I built a board game that can be played remotely. Dog is played between two teams of two players. The aim of each player is to get their pieces from the out area all the way around the board to their home fields. Once all pieces are home, players can support their teammates. The game ends once one team has brought home all 8 of their pieces. To move, poker cards are used. In general, the card's value corresponds to the number of fields you can move. There are, however, exceptions, like the 4 to move backwards or the Jack to exchange pieces. And of course, you can throw others out by moving to the same field. While very fun to play, the game has one major flaw. All players must be physically in the same location. To circumvent this problem, I built an electronic version of the game. While the idea behind the game remains the same, the appearance of both the pieces and the cards change. Instead of cards, each player has a display. There, the cards are shown as characters. To use a card, it is selected and once certain, confirmed using the next button. The pieces are replaced with LEDs. You can move a piece by selecting it and then its path or directly its target. To confirm a move, again the next button is used. But an electronic version of the board is not enough to allow players at different locations to play together. To this end, several boards are connected using a server. A remote game can then be registered on the server's webpage. Next, the different players and their locations are entered. Upon starting a game, codes for each participating board are generated, which then have to be entered at each of them. Once everyone is ready, the game proceeds like a normal one would. Adding some sort of audio or even video connection, using for example Skype, we end up with a version of Dog that eliminates the need for your family or group of friends to negotiate a day on which everyone can make the journey. Let me show you how the electronics behind the board work. The brain of the board is a Wemos microcontroller, basically a tiny computer that controls everything that happens on the board. It is also able to connect to a wireless network and communicate with a server. The LCDs are connected directly to the Wemos. A setup is used where only 2 wires are sufficient for the communication to all 4 screens, called an I2C bus. Controlling the LEDs, on the other hand, is a much more delicate task. Therefore, a separate microcontroller is used, one from the @Tiny family. It receives its tasks directly from the Wemos via a single wire using a custom protocol. As there are a lot of LEDs, not every single one can be turned on and off individually. Electronically, they are wired in rows and columns. If one row and one column is activated, exactly one LED turns on. If several LEDs are turned on and off in this way in quick succession, the eye can no longer see the flickering. The rows and columns are activated using multiplexer ICs. ICs are those black beetle-like things you often see in electronics. A multiplexer IC connects one input to one of several outputs, depending on what the microcontroller wants. The buttons are wired in a similar fashion. If one button is pushed, exactly one row is connected to one column. Having a rough idea how the boards work, let's assemble one. Building a board starts with the wooden top. The required holes are cut using a laser cutter. After cleaning up the holes and sanding the board, it is coated. In the next step, the screens are mounted. First, the connector cables are soldered on, then the whole assembly is screwed onto the board. The rest of the electronics are all mounted to one large PCB. The LEDs, buttons, as well as all the logic are soldered on. After testing and 3D printing the fields and the Wemos housing, everything is ready for the final assembly. To this end, the fields are inserted into the board and screws are fit to the PCB. After aligning, everything is screwed together. As a last step, the screens are plugged in and the feet are attached. And in just under 1 minute, we end up with a fully assembled board. All in all, I am very happy how my version of the board game Dog turned out. It is in fact the second iteration, improving greatly on both usability as well as assembly complexity. However, a board comes with a significant price tag. Building 5 boards at the same time resulted in a per board price of well above $100. While the electronic board is just as fun as the original version, playing over the server could be more immersive, as sometimes the notifications on the screens are easily overlooked. Having some sort of acoustic feedback when the remote person pushes a button, or a digital card pile in the center, might have to be included in a next version. Do you have an idea for a feature or improvement for the board? Let me know in the comments below. Well, that much for now. Thanks a lot for staying with me.